Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Pother, or Pother, I think, by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means that every cell in the grid place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have the sum of the digits along an arrow is equal to the digits in the digit in the attached circle. So, for example, if this were say 3 and 5, this digit would have to be 8 because the digits along the arrow must sum up to the digit that's in the attached circle. And we have every set of 3 adjacent set digits along a peach line contains one low digit, 1, 2, or 3, one middle digit, 4, 5, and 6, and one high digit, 7, 8, or 9. So these are known as entropic lines, and you could have something like, say, 6, 3, and 7 here, and that would be valid because these 3 digits have one low digit, which is 3, one middle digit, which is the 6, and one high digit, which is the 7, in this set of 3 adjacent digits along a peach line. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the one that sticks out to me the most is this cell here. This is the sum of 3 unique digits, so it's at least 1, 2, and 3 added up. And this must be a single digit, so it must be at least 6 plus 1, which is 7. So this has to be 7, 8, or 9. These can only be 1 through 5 added together. So we have a high digit here. This is 1 through 5, and this cannot be, this is only 1 through 3 as a possibility here. So this is a low, guaranteed. We have a guaranteed 1 in one of these digits. We have 1 of each set here. Here, we have 2 of a set. Here, we have 2 of a set. And one of these sets has to be a duplicate. We don't know which. We have 1 of each set here. These are 3 digits, 1 through 6, adding up to a 6, 7, 8, or 9 here. These are 1 through 6, adding up to 6, 7, 8, or 9 also. Same with this set. And same with this set here. Adding up to 6 through 9. One thing, though, that we know is anytime you have 3 unique digits adding up to a single digit, you have to have at least 2 of those digits be from 1 through 3. And you could just figure that out by just trying them out. 1, 2, and 3 add up to 6. So adding up to 6, you have 1, 2, and 3. That's 3 digits requiring that are 3 or less. 7 requires 1, 2, and 4. That's 2 digits that are 3 or less. 8 requires either 1, 2, 5 or 1, 3, 4, both requiring 2 digits that are 3 or less. And 9 requires 1, 2, 6, 1, 3, 5, or 2, 3, 4, both requiring 2 digits that are 3 or less. So in these boxes, particularly the ones where we have 3 entropic cells, we have to have these digits. One of them has to be a low. So this cannot be 1, 2, and 3 adding up to 6 here. Neither can this be 1, 2, 3 adding up to 6 here, because we have a guaranteed 1, 2, or 3 on this entropic line no matter what. So this is guaranteed to be high. We have 2 lows here and 1 medium. So the remaining digits, we have 1 low and 1 high here, and 1 medium. So the remaining digits in the box have to be a medium high pair. Same with this. This is high. We have 2 lows and 1 medium here. This is 2 lows and 1 medium here. So this has to be a high medium pair. We have 1 of each here. We have 1 of each here. We have one of these has to be. We have 1 of each here. This could be all 3 lows here. We just don't know. These we don't really know either. We have a guaranteed low in one of those 3 digits. One of these is guaranteed high. We have a high here. If this is a high, we have a guaranteed high here, a guaranteed high here, a guaranteed high here. Neither of these can be high, so this would have to be high here. One would be low, one would be medium here. So this would be high. This is the same set as this. This is the same set as this. Well, what I'm thinking is, okay, so if this is high, this is low, medium. We have one guaranteed high here. This is low or medium, and therefore this must be high here. If this is not high, it has to be a 6, which means this is 1, 2, and 3 adding up. Which means this can't be 1, 2, or 3. None of these can be 1, 2, or 3, so these are both. These would have to be, neither would be low. This couldn't be low. We'd have to have 2 lows there. So neither of these would be low. This wouldn't be low. So low would have to be here. So low would have to be here. Low would have to be here. This couldn't be low. It would have to be medium, which means this would have to be 2 lows there. Which means we wouldn't have a low in the rest of the column. These would all be low. This would be low here, so this couldn't be low here. This would be medium. So this would then have to be high. No lows here. These would be both be low in that case. So this digit would be the same as that one, because it can't be the same. This is high and medium. This is high or medium, one of each. This would be a 6 in that case and be medium. We have one of each here. So whichever one this is, this one's the opposite. So we'll make that yellow and pink. This has to be opposite of that because we have one of each here and one medium and one high here. So we'll make that yellow. So this is pink, yellow. Yeah, this can't be 6 because we have a medium with 2 lows here. Adding up cannot be 6. This is yellow. That would be yellow. One of these would be pink. The other one would be blue. But this can't be blue, so this must be pink here. So no pink here. Therefore, this would be blue here. This is one of each. We have one of each here, one of each here. Whichever one this is, the other one has to be blue, and the other one must be opposite. I mean, that works. Well, if this were the case here, we'd have to have, these are 2 digits from 1 through 3. This would be a digit from 1 through 3, obviously. So we would have no more digits from 1 through 3 in the rest of this row. So these would all have to be medium or high. This would actually obviously have to be higher than that. We'd have one low here. Um, Unfortunately, that doesn't tell us too much. We'd have one medium here, 2 mediums. So one more medium here, and the rest would be high digits. This can't be medium. If this is medium, all 3 of these are high, and we don't have any more highs in box 8. So this would be high then. We have 2 highs here. One of these is high, so the rest would be low or medium. So that potentially could work. Ugh. Oh, these are both low. And one of these 3 is low. So therefore, the rest of the box could not be low. So this would be a medium high pair. Therefore, this would have to be low here. So this would be a medium high pair there. We have one high here, one green. This is one green, so these are all lows here. We have one of each there, one of each, sorry, one of low and high here, one each of low and, sorry, medium and high here. Which means one low here, which means this would be low here. So we'd have 3 lows already in row 1, so this could not be low. It would be medium, which makes both of these low. None of these could be low here because of the lows in the box, so low has to be there. This is medium and high. This is medium and high as a pair. So these would be opposites. Make that medium, that dark. So these are one of each, so this would have to be dark here. This is medium. We have a high. So these are one each here. Only one of these is low, so therefore we'd have to have a low there. Okay. No more lows here, no more lows here. Where are the... We have two lows, so this can't be low, therefore this would have to be low there. This is dark, this is dark. These are a pair of digits. Don't really have much information though. This is high and medium. This is a pair of digits too. We don't know which. 1, 2, 3. One of these is low. So this can't be low here. It's medium or high. So we have a guaranteed low here, which means none of these can be low. And this can't be low. That's the medium, which makes this low here as a pair. Therefore, this is low and high as a pair. This is low. That means this is medium and high as a pair. One of these is low. We don't know which. These are medium and high as a pair. Where's the last low? It has to be there. That leaves this digit as not that one. Don't really have much more information there. Supposedly this works. This is medium or high. I was hoping that this would lead to a contradiction, but it seems like it's actually fine. I mean, it's pretty restrictive, but it just doesn't... I don't see any issues with it right now. Can we get somewhere else? What happens if this... Okay. What happens if this is 6, I guess? If this is 6, these would all be low. So this would be medium. These would all be low. So the rest of the row would be all mediums or high. We have only one low here, which means we only... These aren't low, so we would have to have one of these be low, and this would be low. So this couldn't be low. It would be green or red. One of these would be low here. And we'd have a contradiction. There we go. So one of these would be low here, which means one of these is low. We have a low here, and low here. But we have to have a low here because of the entropic rules. So this cannot be 6 here. So this is 7, 8, or 9. That's what we were hoping for earlier, but unfortunately that's... Anyways, this must be two mediums and a low. Sorry, two lows and a medium here. We don't know which. Hmm. This cannot be two lows here. But we could have two mediums. Hmm. Um, hmm. This is two lows and a medium. What else do we have? At least one of these is a low. And obviously a medium there and two lows there work. So that's not an issue per se. Hmm. Can this actually be 7? Let's try that. 7. These are all guaranteed lows. One of these is guaranteed low. So that means this must be a low medium pair. And then this has to be low here. That eliminates lows in the rest of these columns here. So this is guaranteed to be low there in that case. This is a 1. So obviously there's no 1 here. 1 has to be here, so 1 is eliminated from here. So this is 2, 3, and 4 here, guaranteed. So one of these is medium. No, this is... Right, these are all lows. This is 1, 2, 3 plus 1. This is obviously not low here. One of these is low. This has to be 9. 1 cannot be here, so 1 is one of those two. 9 cannot be here. That means 1 has to be one of those 3, because any digits with that, any 3 unique digits that add up to a single digit that's not 9 has to include a 1. So 1 can't be here, 1 can't be here, 1 has to be there in that instance, which means this must be a low correspondingly. This is low, that's low. So these can't be low, which means low has to be there. This is medium and high. One of these is low. This is the same as that. Seems like it's okay. I was hoping we'd again lead to a contradiction, but we're not. Huh. Can we ever have a low in one of these 3 cells? If we have low here, we have 2 guaranteed lows here, so this cannot, but we can't have 3. So this would then be high. We'd have to have a low there. The rest of this box would be medium or high, medium or high. No more lows here, that'd be medium or high, which makes that low and low there. So this can't be low. None of these could be low. One of these is low, so these can't be low. So this is medium. This can't be low. So this has to be low, low here. And we show that that's fine, right? What about if we try to make this low? Actually, let's try to make this low. Now that's interesting. So again, these could not be low. These could not be low. We have one low here, so that means these two must be low. So we have two lows here, one low here, the rest cannot be low, so this can't be low again. That's medium. So that's low, two lows here. One of these is low. One of these is low. This can't be low though, so this is medium or high. Makes that medium or high. We have two lows here and a medium. This is also a medium. Hmm. These are two lows. Um, um, okay. What happens if we make this low? Um, keep trying things, it just doesn't work out. We know this is high. These are low or medium. 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 And these are low or medium. Hmm. Hmm. Uh, What we know is this can't be 3. If this is 3, this becomes 1 and 2. This digit is from 1 through 3. This digit is from 1 through 3. And we have 2 digits here from 1 through 3. That's 4 digits, 4 cells requiring the 3 digits 1 through 3, which is obviously not going to work. We could have 4, though, there. So this is 4 through 9. But that's not that restrictive. This can't be 3 for the same reasoning. Well, not same reasoning. We cannot have 2 low digits here. So this is at least 1 medium and 1 low. So this has to be at least 5. But it's not really that restrictive yet. Okay. Um, hmm. If this is 6, that's not gonna work. If this is 6, this becomes a 1-2 pair. That forces this to be 3, but then this can't be 1, 2, or 3. 3 plus 4, 1 and 2, adds up to at least 10. So 6 cannot be there. That doesn't really tell us too much, though. Um... Hmm. Um... Huh. Wait a second. These 4 and these 3 digits add up to the same sum as these 2. Oh, that's... Yeah. 1, 2, 3, 4 plus 1, 2, 3. So 6, I don't think, can ever be there, right? 1, 2, 3, 6 adds up to 12. You could have 9 and 9, though. Right, that could work. Yeah. Um... Yeah, so they can add up to 18. They have to add up to 16 at least, but that does mean that 7 is still available. Now, the interesting thing is adding these, right? So that's 1, 2, 3, 4. And 1, 2, 3, 4 plus 1, so that's 21. But this could be 9 and 9. And this could be any number of digits. What about these? Interesting. So we have 1, 2, 3, 4, 5. That's 15 at minimum. 1 and 2, 18 at minimum. Plus 1 is 19 at minimum. That doesn't help us much. 19. But these could already be 17. Like, this is, yeah. 4, 6, and 9 is 19. Seems fun. Hmm. Uh, um, hmm. Seventeen, 26. Well, we know. Can we? 1, 2, 3, 4. 1, 2, 3, 4. It's 20. Can we have 27? The answer is no. Because we cannot have 3 nines here. We can have at best an 8 and 9, which is 17, plus 9, which is 26. So this can't be high. But we kind of already knew that. This is lower medium. Hmm. Okay, so we know these map to these cells here. So this maps to that. This maps to that cell here. This maps to that. Hmm. So these two are the same sets as these two. These two are the same sets as those two. Does that tell us anything, though? We don't really have very much information here with either of these. Because the problem is you could have repeats on in these sets of three, right? Ugh. Um, what happens? Okay, what happens if this is high? If this is high, we don't have a high here, so we're guaranteed this has to be high there. This is low and medium. Hmm. Um, that doesn't help us much. Yeah, that doesn't really help us much. Oh, that does help us a much. So if this is not 6, this is high. We have one high here. The rest of the column is not high. So this has to be medium or low. That means this has to be high here, which means this is medium or low. But where is the high then in box 6? Only one of them can be here. We have a high here, and we don't have a high anywhere else, which means this cannot be high. And we now have the solve. So this cannot be high, which means it has to be medium and a 6. That eliminates 4, 5, and 6 here, and then the way that we're going through, where we're trying to find a contradiction here, means it can't be a contradiction. It's actually the solve. So this must be medium here, because we have 3 lows already in column 2. We can't have 6 here. This is 2 mediums and 2 lows and 1 medium here, which eliminates the lows of the rest of the row. So no, this can't be 6 here. We cannot have a medium here, because if we had a medium here, we would guarantee this has to be medium or lower, but then that would be 4 mediums or lower. We already have 3 lows in the row. We have 2 mediums. And if we had another medium here, then we cannot have another medium here, which was contradiction. So this is 7, 8, or 9, which is a high. These are all lows, so these cannot be low here, which means this has to be low here, and low here because this is a green-red pair. This can't be low. 1, 2, 3. This is 4, 5, or 6. This must be with 2 lows here, which is 1, 2, or 3. That gives us 3 lows already in column 3, so this cannot be low, which means this is medium. Therefore, this can't be medium here. These are 2 guaranteed lows, because again, anytime you have 3 digits adding up to a single digit and they're all unique, they must add up to, they must have 2 digits that are 3 or less. One of these is 3 or less, so the rest of the box cannot be 3 or less. So we have mediums or highs here. This is medium. We don't know which one this is. One of these is low. This must be low here, so this is a green-red pair. We don't have any more lows here. This is green-red pair, green and red, but this can't be green. If this is green, all of these are red, and we have a guaranteed red here. So no green there, it's red. One of these is green, one of these is red. One of these is green, one of these is red. That just leaves us blue and green left in the box. We have a medium here. That's fine. These are not low, these are low and high and medium as a pair. That makes this low there. This is green or red. One of these is low. This can't be... Well, we could have a low here. We have low and low here. We have only one low here, which means that the last digit has to be low. We have 3 lows in row 1, so the rest cannot be low, so this is medium here. And since this is at least 4, 1, and 2, these have to both be low. That means these can't be low, so this is medium and high, which makes this a low there. That means this is medium and high. These have to be one of each also. This cannot be 3. Because it's at least 1, 2, and 4 here, which is 7, plus 2 could add. So 7 means this has to be 8 or 9. No more lows in row 1. We have one blue here. Only one of these can be blue. So blue has to be here. Therefore, one of these is blue. This is blue. Because one of these two is blue, one of these two is blue, so this can't be blue, which means that's green. No green here, so this is 4, 5. These have to be a 1, 2 pair, 1, 2, 3 triplet. One of these is blue. This can't be blue. It's green or red. This is a green-red pair. None of these can be blue because one of these is blue here. So these are all green and red. That means this has to be blue there. The remaining digits in row 3 have to be blue and blue. That means this can't be blue here. This is green and red, green and red. This is green and red. One of these is blue. That means one of these, we have all green and red in row 4, so this must be blue here. That means this can't be blue. This is green or red there. This is blue with green or red. We're not sure which, though. And then one of these is blue. I'm not sure. So this is green or red here. Okay, let's start trying to figure out which one has to be which. These are different sets. So we'll make that yellow and orange. That means this must be orange there. That must be yellow there. These have to be different sets. We'll make this the same as that, so we'll make that medium. And then this has to be dark, so this has to be dark. Okay. We have one of each here. These are one of each. These are one of each. And we have a high here. So this cannot be high. This must be medium. And we have one of each here, one of each here, and this is medium, so this can't be medium there. That's high. Okay, that's interesting. These have to be opposite sets too, but we don't really have any information there. This is medium. We have one of each here, one of each there, so this must be dark. We have one of each here. No, actually, one of these is blue, but we don't know. So we have one of each here, but that doesn't tell us too much. This is green. We have one of each here and one of each here. That gives us all the greens in row 6. So this must be blue and red, which means this must be blue and red. So this can't be red. That's green. We have blue and red here. We have a red here and a green. So we have a red here, a green here, and one of each here. Therefore, this is dark. This has to be the opposite color, so this must be medium. So one of each here, one of each here. And this is blue and red, which means this must be blue and green here. Yes, and that satisfies that. Because we have a medium and a dark here, and then we have 2 reds and 2 blues. Okay. Oh, now this is interesting. This is at least 1, 2, 4, 5. We know this is 1, 2, 3. 1, 2, 4, 5 adds up to 12. 1, 2, 3 adds up to 6. That's 18. Therefore, both of these must be 9. So this is then 1, 2, 5. 1, 2, 4, 5. Because we know this is a low. So this has to be 3. Therefore, there's no 3 here. And this has to be 9 here. This is 1, 2 as a pair. 1, 2 eliminates 1, 2 here, so it's 3. We have 1, 2 here. This can't be 3 because of 3 in the column. We have 3 lows in column 5, which eliminates lows in the rest of the column, so no low there. It's green. We have a green here, a green here, and green here, which eliminates green in the rest of the box. So these are both low. We have 3 lows in row 7, which eliminates lows in the rest of the row, so no low there. That's high. This can't be high then. That's low. That's the same set as this, so this is low, no low here, it's high. We have 3 lows in column 8, so this can't be low, it's medium. This can't be medium, it's low. Okay. One of these is 1, 2, or 3. This is 1, 2 as a pair. 9 cannot... This has to be 9 and 9 to add up to 12 plus 6, which is 18. So this cannot be 9 here. We have 6 here. This can't be 5 because of the 4, 5 pair in the row. The remaining digits have to be 6, 7, or 8. Interesting. This digit plus is the sum of these two. So this is at least 4 here. 4, 5, 6, or 7. Interesting. Where is 9 in row 2? It has to be one of these 2 digits. Hmm. Three has to be one of these 2 digits here. This must be 1 or 2. This can't be 3 because of 3 in the column, so that's 1, 2. We have a 1, 2, 1, 2 pair in row 4 and column 4, or box 5. That eliminates 1, 2 in the rest of the row and box. So this is 3. This can't be 6 anymore because 1, 2, and 6 adds up to 9 at minimum. 1, 3, and 4 at minimum, so this can't be 7, it's 8 or 9. 3 has to be that one because of the 1, 2 pair in the box, so this can't be 3. Therefore, 3 has to be one of those two there. We already knew 3 is one of those two. 3 can't be here. 3 has to be one of those two digits. Hmm. This is a low. So 1, 2, 3. But this could be 4 through 8. No 6 though. Where is 9 in box 7? It has to be one of these three digits there. That means 9 cannot be any of these digits. So 9 has to be one of these three there. This digit cannot be here, so it has to be the same as that. So we have A, and that must, one of those two must be A. Can we ever have 3 be there? The sum of these digits would then be 3 and 1 at minimum, 3 here. So we have 3 plus 1 and 3, that's 8, plus 1, 2, 3, 4, 5, that's 23. That could work if this is 6, 9, and 8. Yeah, that's fine. So we know A here has to be the same as A here, which has to be the same as A there. Not helpful. Oh, now that's interesting. If this is 3 and 3, this is, we know this is 1, 2, 4, 5 at most. Oh, that's very interesting how that works, interacts. So if we have 3 and 3 here, this can't be 9 anymore, but it could have 3, 5, and 9 there. Um, So we have B and C. We have A, B, and C here. B cannot be here, so this is A and B here. And we have A, B, and so C has to be here. B and C are both here. So C is here. It's interesting. A and B are summed up. A is summed up 3 times. B is summed up once. Sorry, twice. And C is summed up once in these arrows. These arrows could be 6, 9, and 9, which adds up to 24. Or these digits in the arrows, in the cells related to the arrows, can be 6, 9, and 9. Can we ever have CB1 is the question. So C's counted once. Can we have C1, B2, and A3? I think the answer is probably no, right? That would be 1, 2, 3, 4 at minimum, 4, 5 at minimum. That's 15, plus 2 and 3. Oh, no, that's fine. 15 plus 5 is 20, plus 3 is 23. Yeah, that's fine. Well, what's interesting if this is 1. If this is 1, this has to be 7 or 8 there. This digit has to be the same as that. Okay, so let's make this is D. Make this D and E. D can't be here, so this must be D, which makes this E, which makes that D. This is E. That makes this D there. Maybe we should just color this. Yeah, maybe coloring this is better. Okay, we're gonna change these to green-red pairs. We're gonna change the 1, 2 pairs to certain ones. We'll make it orange and pink. We don't really have that information, do we? You know all of these are 1 or 2s. Okay. That's just arbitrary. Yellow and orange. So yellow and orange. This is not yellow, so that's orange. This is not orange, so it's yellow. Orange eliminates orange there, so it's yellow, which makes this orange. Yellow means this has to be orange there. Orange means orange can't be there, so orange has to be one of those two. Which means it's B or A. This can't be orange. This can't be orange, so orange has to be here. Aha. Which means this can't be orange there. Nice. Yellow's here, so this must be yellow there. This is orange there. This has to be orange there. Which means this has to be a 3. So there's no 3 here because this is orange. Orange cannot be here. I don't know which one of these it is. 3, this is 1 or 2, so this is yellow. And it's C, so it has to be here, which means it has to be there. So there's no 3 there. So we can remove the C's here. And one of these is yellow. Orange, so we know this is orange. It cannot be, so this has to be 3 here. So we don't know. This is guaranteed 3, so this is at least 8 or 9. We don't need the blues, really, anymore. We know. So this is 1 or, yeah. This is 1, 2, and we put up 3 there. So we don't need the blues. Because those are essentially yellow or orange. So we know these two add up to 6. We know these two add up to 6. Because 6 plus 3 is 9. 6 plus 3 is 9. Oh, this is orange. That means this can't be 3. So we have to have 3 here. This cannot be 7 or 6 here to add up to this. This is 7 or 8 here. And this is 3 and 4 adding up to 7, 3 and 5 adding up to 8. So this is not high, it's medium. We have 3 mediums in column 8, which eliminates mediums in the rest of the column. That's nice. We have 3 highs in box 9, which eliminates highs in the rest of the box. So this can't be high. This high eliminates high there, so that's medium. That means this can't be high, it's medium. Can't be medium, it's high. This is a high digit here, which means this is a 7-8 pair. That means this can't be high. It's medium and is 6. That eliminates one of these is medium. These two are medium, so that eliminates mediums in the rest of the box. So this is high. We have 3 highs in box 3, which eliminates highs in the rest of the box, and no high there. So this cannot be 9. Which means 9 has to be there. These are one of each. This is orange, so this can't be orange here. It's yellow. We don't have any information here, unfortunately. So this can't be 9, which means 9 has to be one of these two in row 9, so no 9 there. It's medium. Okay. Not too helpful, unfortunately. So we know 3 is included at least twice here. Remaining digits of row 2. We have 4, 5, 6, 7, 8. Nope, 7, 8 here because of 7, 8 pair. It's 4, 5, 6, 4, 5, 6, 4, 5, 6, 4, 5, 6. 6 has to be one of these 2 digits there. So where is this 6? 6 can't be here because of 6 in the column. Where is 6 in row 8? Cannot be here because of 6 in the box. Can't be here because one of these must be a 6. So 6 is required to be there, which means this is not high. This is not medium. This is not high. That's not medium. We have 3 mediums in column 5, so this can't be medium. That's high, which eliminates high there, so it's medium. That means this can't be high here. This can't be medium here. 7 or 8. We have... Again, this is 3 mediums in column 5, so this cannot be medium here. It's high, which is 7 or 8. So this cannot be 3 plus 7 adding up to this. We have 3 highs in row 9. This can't be high. It's medium. So this can't be 3, which means where's the 3 in box 8? It has to be here. That's not yellow. And this can't be 3 here, so this is orange. That leaves this as a 3 here. This is orange. That means this can't be orange here. It's yellow. This can't be yellow here. It's orange. Okay. These have to be a 4-5 pair, though. Interesting. So now let's color the corresponding green. These two add up to 6. These two add up to 6. So this is green. Sorry, this is orange. This cannot be orange here. It's yellow. Which means this is the orange 4-5 here. And orange 4-5 plus orange low is 6. 6 plus 3 is 9. So that's 9, which means this can't be 9 here. Whereas the 9 remaining in box... yeah, box 6. It has to be here. That eliminates 9 here. This must be the orange 4-5. This has to be 6 because we don't have a 6 available in that column. That means this can't be 6 here. This is orange 4-5, so this can't be orange 4-5. One of these two is orange 4-5, but we don't know which. This is yellow 4-5. Mix this orange 4-5 here. That leaves this as yellow 4-5 here. Yellow 4-5. Okay, so we have yellow 4-5 has to be here and here, which leaves one of these as yellow 4-5. Orange 4-5 cannot be here, so this must be orange. One of these is orange 4-5. So this is the orange and yellow 4-5 pair. That means this can't be 4-5. It's not, therefore, 6 here. This 4-5 pair eliminates 4-5 in the rest of the row. This can't be 6 because of 6 in the column. So this must be high, which means 6 has to be there. And it is not high, so that's this is high eliminates high here, so that's medium. We have 3 mediums in column 2, which eliminates mediums in the rest of the column. So these are not mediums, these is high. This medium eliminates medium here because it alternates. This is the orange 4-5 here. These are both high. That eliminates high in the rest of the box. That means this is 6 here. And this is 4 or 5 here. Okay. Yeah, we don't know which one of these is which. This 4-5 pair eliminates 4-5 here, so that's 6. No 6 here. This is then the yellow 4-5, which means this can't be yellow 4-5. It's orange 4-5. That makes that yellow 4-5. This can't be yellow 4-5. It's orange 4-5. We have 3 highs in row 4, so this can't be high, which means this is medium. That's yellow 4-5. Whereas the 6 remaining, it must be there. This can't be medium here. It's high. Yellow 4-5 has to be one of these 2 digits here. And orange 4-5 has to be one of these 2 digits here. Okay, that doesn't help us much. This is 7 or 8. This is 7 or 8. This would be 7, 8, or 9. 7, 8, 7, 8. 7, 8. 7, 8. 7, 8. This is obviously 4, 5. 1, 2. 1, 2. 7, 8, or 9. 7, 8, or 9. 7, 8, or 9. 1, 2. 7, 8 here. Oh, that's interesting. We'll color this then the orange 7, 8 here. Let's remove red and green. We'll make this orange 7, 8. This is going to be yellow 7, 8. Orange 7, 8 means this is yellow there. That makes that orange 7, 8 there. This is yellow. This is orange. Hmm. Huh. This is medium, so this must be medium here. It's 4, 5. That means this is orange 4, 5. That makes this yellow 4, 5, which makes that orange 4, 5 there. Which makes this yellow 4, 5 here. This is 7, 8 here. That's yellow 7, 8. Means this can't be yellow 7, 8. That's orange 7, 8. This is yellow 7, 8. That's orange 7, 8. You have yellow 7, 8 there. Okay. So these are 2 oranges. That adds up to 6 plus 3. So this is 9, which means this can't be 9 here. This is 7, 8 as a pair. 9 eliminates 9 here. Orange 7, 8 makes this yellow 7, 8 here. That makes that... Oh, well. That makes this orange over there. That makes that yellow. This is orange. We have 7, 8 as a pair in row 6. This can't be 7 or 8. It's 9. Orange 7, 8 is here, which makes this yellow 7, 8 here. So these are opposites. Well, okay. Let's think. 4 and 7 go together here, and 5 and 8 go together here. So if we had let's try orange as 2. If orange is 2, that means this is 4. 3 and 4 add up to 7. So the yellow 7, 8 would be 8. So then we would have 2 and 8 here, which does not work. So orange 1, 2 has to be 1. So these have to be 1. That means the other 1, 2s have to be 2. The orange 4, 5s have to be 5. And the yellow 4, 5s have to be, well, let's remove the 2s from the yellows. The yellow 4, 5s have to be 4. Remove the yellows from there. So 3 and 5 add up to 8. So the orange 7, 8s are 8. The yellow 7, 8s are 7. 1 and 7 then adds up to 8. This is 7, 8, and 9 there. This is 7, 8, which makes this 9, which makes this an 8 here. This puzzle was inspired by this lovely puzzle by Gene. Interesting. It was, yeah, very cool. It was interesting how those things interacted. The break-in was kind of tough. And finding that was hard. But eventually you got there, right? If we have 7, 8, 9 here, and 7, 8, 9 here, one of these is high, therefore none of these are high, which means this has to be high here, which means none of those are high, but this can't be high, and only one of these is high, and therefore that's a contradiction there. But that's not easy to spot, I don't think. You just have to basically think things through and try to logic it out. But it's pretty difficult, I would say. But once we got that, then everything flew in place. But is figuring that out, which was the hard part. Also, like, I think it was kind of cool actually, the interactions between the 1-2s and the 4-5s and then the 7-8s. That was actually really cool. I enjoyed that. Um, it's not obvious for that either, but for some, that one just clicked to me. I was like, oh, I need to find all the 1-2s, figure out what those are, figure out whether those match with the 4-5s, and if they do, then we know that that adds up to 6, and then plus the 3, that gives us 9, right? So that made things kind of simpler. That also allowed us to clear all the 3s, which was helpful. Yeah, nice little puzzle here, though. That was very cool. I enjoyed it. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.